Sorry, especially in Azure data engineering, two topics we have pending. Till now we discussed about Azure SQL and Azure Data Lake. What is the latest version in the Data Lake? Data Lake Gen 2. Old one is Gen 1. Now it is Gen 2. Okay. What are the differences between Gen 1 and Gen 2? These technical differences in coming classes we'll be discussing. And Azure Synapse Analytics Service. Actually, your weapon, your daily development tool is Azure Data Factory. And yesterday we discussed about Azure Databricks and Azure Cosmos DB. Still other products we have, that is Azure Streaming and Azure Keyword. Okay. So initial in the beginning, as a ADF developer, you can step into the industry with this skill. But you will have to interact with other products because you are fetching data from Azure SQL, dumping into Data Lake and dumping into Synapse. Again, from the Synapse, again, you are performing some transformations. That means you need to regularly interact with other products. Okay. 90% of your work with ADF, but in every work, in every pipeline of ADF, source as part of source and targets, you are interacting with them. Got it. That's why that knowledge is also required. Later, for once joined as ADF developer, then update the skill of Databricks. That is Azure Databricks in Azure platform. What is simply Databricks? Your comment? As per yesterday class. Databricks, Azure Databricks provides Spark cluster with autoscale. What is the meaning of autoscale? As workloads increases, automatically number of nodes will be added. Again, when workload decreases, automatically the number of nodes will be come to the normal state. Okay. So auto scaling, the same Spark cluster with auto scaling in Azure Cloud Platform. Okay, that is Databricks. So that Databricks is responsible to provide you that kind of cluster. And additionally, for Spark related, some additional libraries also it is provided. Got it. Suppose machine learning related libraries, NLP, natural language processing related libraries, that kind of libraries also given by the Databricks. Difference between Azure Databricks and Databricks. Databricks independently available. Databricks independently available. Again, in Azure, you have Azure Databricks. What is the difference? Databricks also cloud, sir. Databricks also cloud. Sir, when you call something as Databricks means auto scaling is with that one. My question meaning Databricks is there. Azure Databricks is there. What is the difference? Sir, simple, same Databricks in Azure. That is called Azure Databricks. Okay. Azure Databricks is compatible with Azure storage services. In Azure, you have different varieties of storage services. Azure SQL1 storage, Azure Blob storage, Data Lake Gen 1, Data Lake Gen 2, Azure Cosmos DB, Azure Synapse. In this way, many storages we have. This Azure Databricks is compatible with all Azure storage services. Got it? Same thing. AWS has AWS Databricks. That is compatible with AWS storage. Got it? Okay. Then come to the Cosmos DB. Please recall what is Cosmos DB. Cosmos DB, especially, okay, you said online transaction processing something, right? Especially for the OLTP systems, for transactional databases. You can use two things. One is RDBMS. Second one, NoSQL. Understood. Second one is NoSQL. Problem with RDBMS? Only structured fixed. At the time of creating table only, you are fixing some structure. If a column which is not available in the table, you cannot insert that. For example, your table is employee. You have only ID, name, salary columns. All records should follow that structure. For any record, if additional field is required, you cannot insert it. Within the limits of structure, you have to work. But this is regularly for employee, this is okay. For customers, this is okay. But for product catalog, this is not okay. Because you are an online seller. You are selling your products through online in the way of e-commerce. Daily, you are adding so many products. Product to product properties, that means attributes are different. If I fix a schema, if I fix a structure, suppose you fixed a structure for your laptop. Suppose if it is laptop, what are the basic requirement, basic attributes required generally in the fields? You have product ID, the product description, okay, and the brand, and what is the RAM and model, what is the RAM capacity, what is the storage capacity, okay, that means what is the storage capacity, RAM, after that what is storage, what is the type of the storage, okay, and what is the processor capacity and number of cores. In this way, many attributes you will be asking. This is product one you have stored. Product one is a laptop. Product two is TV. If it is TV, maybe one or two are common attributes. Remaining TV has its own attributes. Third product is a book. Maybe price is the common attribute. Product ID, product name, and price is a common attribute. But remaining attributes like author, publisher, volume number, all these things, different attributes. In this way, if there are thousands of products, if each product has its own attribute, you cannot keep all the things into RDBMS database. Because at the time of creating RDBMS table, you are fixing structure. Within the limits of that structure, you need to work it. Got it. But runtime, I could able to enter my new fields. Runtime, at the time of query, I could able to give my new attributes. That is not supported by RDBMS, that is supported by NoSQL databases. NoSQL means not only SQL, and simply in general terms, you can say non-SQL. Okay. That means SQL is generally for relational data, structured and relational data. Got it? But for non-structured data, which is demanding semi-structured kind of things, SQL won't support. At the time, you have to go with NoSQL. A simple example for this. Generally, in case of Cosmos DB or MongoDB, both purposes same. The data is stored in the format of documents. What is a document means JSON record is called a document. The shape of JSON, JavaScript object notation. The data shape is like this. The record started with a left curly bracket. So here field name, suppose the name and field value, something. And second, suppose I am entering his age. Age is 25. I am entering his marital status. He is single. This is record number 1. How many attributes I have for the record number 1? Only 3 attributes: name, age, and marital status. For example, look at second. The name, gender, a spouse, now to specify the time stat. Already spouse is mentioned. I just want to enter directly the kid details. Definitely a single person can have multiple kids. That's why array I am taking. Again, each kid has his own attributes. One more nested JSON record I am taking. The first kid is Tony. He is a male. And age 3 years. It's all the details of the kid number 1. And still she has kid number 2. Let's say the kid name is Sony. And gender female. And age 1 year. Now kids attribute completed. And let's talk about qualification of same person. The qualification is here BTech, MTech, and PhD. Now, in my system, I have 2 records. Record number 1 is about Axie. Record number 2 is about AMI. What is the difference? What is the difference between these 2 records? Record to record structure is different or not? The 2 second record contains complex structure or not? That kind of complex structures cannot be stored and processed in the regular or DBMS databases. Again, third person, Mr. John. John may have his own different attributes. Just imagine all these things in the way of Amazon products. This is the first product details. This is the second product details. Third product might be book. Fourth product might be TV. Product to product, different structure I can maintain. Understood this point? So the collection of records are generally kept in tables. The collection of records generally kept in collections. Collection of documents. These are documents. In Cosmos DB or in MongoDB, we call these things as documents. Each record has a document. The advantage, the document is in the shape of JSON. The advantage, record to record, different structure. Okay, a little deeper. In case of NoSQL, already yesterday we discussed, we have 4 types. Number 1 is key value store. Number 2, document store. And columnar store. And graph store. So every type of NoSQL database has its own functionality. Whatever key value store is doing, document store cannot do. Whatever document store is doing, columnar store cannot do. Every type of NoSQL is good at that particular situation. Suppose your Azure key vault comes under this key value store. The purpose of key vault is different. The purpose of document store is different. Whatever Cosmos we explained now, that comes under document. Okay, MongoDB. Actually, this is inspired from MongoDB database. After MongoDB in the market, CouchDB came into the picture. And after that, AWS has launched AWS DynamoDB. Now your Azure has started Azure Cosmos and DB. There are very good features in the Azure Cosmos DB when compared with other NoSQL databases. Especially in columnar store, the popular things, HBase. And for generally for OLTP, the HBase is used for Hadoop systems. For general systems, Cassandra will be used. Cassandra is columnar store. Whenever you want to do some search activities, the columnar store is very faster. And graph store, the Facebook connections. One user is friend to other user. Directly or indirectly, between the records, the connection is there. That connection is called graphs. For these graphs, the popular database is Neo4j. And also Greenplum. In this way, different databases are there. Sir, one thing, sir, here. If I go with MongoDB, I'm expecting some functionality kind of document store kind of functionality. That is good for that particular thing only. But whenever I want faster searching activities, the MongoDB is not good. I need to go with Cassandra kind of databases. If my requirement is graph data store and graph data processing, then this Cassandra MongoDB are waste. At the time, you have to go for Neo4j because that comes under graph store. Understand the point, sir? So in this way, if I want to implement NoSQL databases for my processes, one single NoSQL cannot solve all my problems.
So what is the SQL where using it? What is the SQL?
SQL structured query language. Okay, that discussion later. This is
so where using in media?
That part yesterday completed.
Actually,
Please, just please listen. If you want yesterday recorded, day before day recorded session, I will give you. So train is on the middle. Train is already with 100 km speed and on the middle of the track. Now don't put raise our hand. The related topic you can ask me. Okay. So just observe this. And also one more point, we are not talking about SQL, we are talking about NoSQL. Okay, there is a revolution anti to the SQL, that is NoSQL. Okay, if I go with one kind of database, remaining things I cannot do. Remaining functionalities I cannot get. Right. What I want to convey the message is, I selected MongoDB. MongoDB is specialized for what? Document activities. Okay. So from this, I cannot process graph data. But Facebook has a requirement of Facebook or any social site or any online e-commerce site has a requirement of graph store, document store, columnar store, and all these requirements there. That means they have to engage MongoDB, they have to engage Cassandra, they have to engage Neo4j or Greenplum, and everything they need to set up. Understood? But in Cosmos DB, you have a great feature, Azure Cosmos DB. Sir, if meeting time is up, please join immediately in the same meeting. Meanwhile, I will complete this. it has API option. At the time of creating Cosmos DB option only, that at the time of creating Cosmos DB, you can choose the API, the type of API. Suppose if I select SQL API, this Cosmos DB, I can run my SQL queries on the Cosmos DB data. At that time, my Cosmos DB data objects are acting as tables. Okay. For another instance, at the time of creating other instance, I will select Graph API. If I select Graph API, at that moment, my data objects are acting as nodes and edges. Your Facebook user is a node. You are one node, I am one node. The relationship between you and me, that is called edge. Okay, in the graph data, the data objects like nodes and edges. So if I choose the API for the Cosmos DB, Graph API, it will act as nodes and edges. If I choose SQL, it will act as table. Got it? If I choose Cassandra API, it will act as columnar store. Within the columnar store, you have row keys. Under row keys, you have column families. Under column families, you have column values in this special structure. On that way, based on what API you have selected, according to that, your data objects will be behaving. That means if I go, what is the additional advantage here when compared with others I am getting? If I choose Azure Cosmos DB, I will be getting benefits of all NoSQL databases. Suppose all these NoSQL 4 requirements are at a time required to me. At that moment, I will go for 4 separate instances. Instance number 1, there I will use SQL API. Instance number 2, there I will use Cassandra API. Instance 3, I will use Graph API. Got the points? In this way, single NoSQL database can behave like different types of NoSQL database. This is one benefit. And also one more benefit. Nowadays, this benefit is only with the cloud related databases only. You have worldwide business, sir. Your business is with worldwide. Suppose you take best example again, Amazon online sales. They are doing business not only in India, they are doing business in entire world. Got it? Suppose think that they want to set up 25 major regions, like the 25 sales points. Suppose if majority of the customers are from India, if Indian customers are connecting to India region, American customers are connecting to American region, but data same. Okay. Suppose I'm booking an order. So this order should be connected with, this order request should be connected with India region. From Indian server, it has to fetch the information. Suppose you are American, you are from some Chicago. You are performing some transaction. Your transaction request to be connected with the Chicago related region. Understood these points? On that way, once if I create my collection means just compare with the table or my database. Once I create a database account for the Cosmos DB, I have an option called replication. The replication I replicate in India region and US region and Germany region and also like Canada region. Why I replicated into 4 regions? My most of customers are from these 4 parts of places. But same data available in all the regions. So what is the advantage of this one? Advantage number 1, my local users are getting faster responses. Second reason, even though one region got down, still your data is available in other regions. High availability and faster response you are getting it. Cosmos DB is process like is promising you whatever the workload may be. In less than or equal to 10 milliseconds, the user will get a response of any transaction, whatever the data load may be, with auto scaling feature in the backend cluster. 10 milliseconds transaction means a good speed, even the workload is very high. Understand the points? Like this. That too, I need not to maintain any infrastructure. Now, being a data engineer, you should be designing the data models for OLTPs and also for data warehouse. Now we have two options for the OLTP in our Azure. What are those? You have two options. One is RDBMS. In the case of RDBMS, what you can keep? Azure SQL. And alternative for the RDBMS for special requirements, you have NoSQL. What is our NoSQL? Azure Cosmos. Benefit of Cosmos. With single NoSQL, you can get benefit of document store, columnar store, and also graph store benefits. Basic behavior in document store. Suppose I want a graph data processing kind of functionality, I can use Graph API. I want such kind of functionality, I can use Cassandra API. In this way, especially by using special APIs, I can change the behavior of the Cosmos. Okay. And in the case of data warehouse, I have RDBMS and also I have file system. File systems for my staging area. What is that? File system here. You have Azure Data Lake, distributed file system. What is RDBMS in the data warehouse? Synapse DB. Okay. In Synapse Analytics, you have a service called Synapse SQL Pool DB. A short name for that, SQL DB, Synapse DB. Both are RDBMS, Azure SQL RDBMS, Synapse DB is RDBMS, but Synapse for data warehouse, OLTP, that Azure SQL for OLTP. If it is OLTP, there should be a special class that it should support ACID property. What is that ACID? In future discussions, you will see, especially for the new guys of the IT. Atomicity, consistency, isolation, D for durability. The OLTP systems should support this ACID properties. Okay, for transactional support. But in the case of data warehouse, ACID properties are not completely required, because in the data warehouse, most of your operations are batch processing and analytics processes, not for the transactional processes. Got it. So the NoSQL should support it. At the same time, RDBMS should support ACID. Then only organizations can use them into their OLTP area. Okay, later. Sir, all of you, the time is up for the meeting. Please disconnect the meeting and rejoin into the same meeting, sir, just immediately. I will just disconnect this meeting, rejoin into the same link. Okay. Please rejoin now.